Okay, everybody, let's get started. I'll say that, Phil already gave this disclaimer over the weekend, but please feel free to jump in and contribute whatever knowledge you have on this stuff. I'm presenting stuff that I know about, but I think a lot of people in the room also know a lot about. So please feel free to, if you have more knowledge or more papers you think are relevant to what we're talking about, please bring that up. And just to give you an idea of the format for today, I'm going to go for about an hour right now with no break. Then there's going to be our 15-minute break, and then Arjun's going to go for 30 minutes. And then in the afternoon, we'll have Bharat and Tomas both presenting for 45 minutes. All of the presentations today are going to be related to evidence about task-based models, different ways of measuring AI exposure, measuring the impacts to date. There's going to be some overlap with what we saw from Eric yesterday, but hopefully we'll go into it in different levels of detail, and that will be helpful. Okay, getting into it. We're going to be talking about the simple macroeconomics of AI, this Acemoglu paper. I'm sure many of you have come across it. I think I made this joke in a different context to Phil or someone else here, but one name for this course you could think of is the not so simple macroeconomics of AI. But this is Acemoglu's paper. So it extends their own framework, Acemoglu and Restrepo's own framework from one of their earlier papers, but it's very similar to the model we saw yesterday from Aghion, Jones, and Jones, the AJJ task-based model. The economy is producing a unique final good by combining a continuum of tasks. The little y is the output of an individual task z, and then sigma, the elasticity of substitution, is going to be calibrated so that tasks are gross complements. In an individual task, you have perfect substitutability between capital and labor. And you have both these AL and AK terms that are kind of average or aggregate labor augmenting and capital augmenting technology, and then also task-specific gamma L and gamma K of Z terms that indicate productivity within that task of labor or capital, which is slightly different from what we saw in the Jones model. But once again, we're going to have a threshold of tasks where capital is used all the way up to a certain threshold, and then labor is used in the remaining tasks, like in the dirt and water models we've been talking about. Yep.
How do we have any idea how substitutable all tasks are?
Yeah.
On labor, at least I can go and measure those things. I don't even know what a task is.
Yeah, I mean, I agree. I don't think we should take the sigma is approximately 0.5 that seriously. I actually don't really know that Humlum paper that he's basing his estimate off of that well. I think in a paper, in the Jones and Tonetti paper we're going to talk about later, they consider 0.3 to 0.7 range. I agree with you, it's an issue. So in this model, there's basically 4 ways that AI could affect production. One is extensive margin automation. So that's just, the T in our dirt and water model, expanding capital, doing new tasks. The next way is task complementarity, which is AI increasing the productivity of labor in the tasks that labor continues to perform. And that could come in the form of the task-specific productivity terms or the kind of aggregate labor augmenting technology term. The third is automation deepening, which would be improving capital's productivity in already automated tasks or reducing the cost of producing capital. And the fourth is creating new tasks, increasing in the measure of tasks. In this Acemoglu paper, he's really only focused on the first 2 channels. And I think that's important to keep in mind when thinking about his estimates. Yeah, Charles.
Think about if there's perfect substitutability within the task, capital not being above the threshold. Is it just gamma K Z 0 below the threshold, or above the threshold, or what?
Well, I mean, it's also going to depend on how much it costs to use capital versus labor, but that productivity adjusted for its costs means that it's less efficient to use capital in that task than labor, and those are the ones that are unautomated. And so then Holton's theorem, for the 3rd time, banging your heads over with it, subject to the caveats from Phil's lecture about the way Acemoglu uses it. what we can ask is, what's going to be the change in total factor productivity if we have a shock to the productivity of a given sector or task's productivity. And that's given by the Domar weight lambda, which is the GDP share of that task, times the cost savings in that task, pi, which is the productivity improvement. And then, for estimation, we just simplify this to looking at the average cost savings across all AI impacted tasks times the GDP share of tasks impacted by AI. If you want the total GDP impact as opposed to the total impact on productivity, you also have to take into account how capital accumulates over time. And that's given by this, but we're not going to focus on this as much. SK here would be the savings into capital. Okay, so there's two key inputs we want to have if we want to have an estimate of, what is AI going to do to TFP. One is the GDP share of tasks impacted by AI, and Acemoglu is looking at this on a 10-year horizon. We're going to talk about both of these papers more in a second, but he's using estimates from this Elandu et al. Paper and the Svanberg et al. Paper to get that. And then the average cost savings in these tasks, which Acemoglu uses these 3 studies of productivity impacts of LLMs, Gen AI, to get at. And note that cost savings bundles both labor automation and labor complementing. And that's what I mean by Acemoglu focusing on the first 2 things. There's both the automation component and the task complementarity component being captured here. Again, if you think of tasks being carved up into smaller subtasks, if we find that someone's productivity increases 20% on a given task, is that because the whole task, their skill, the specific productivity term for that task was multiplied by 1.2, or is it because 20% of the subtasks within that task were automated? We're not actually differentiating between those 2 things. Okay, so getting into this first point about what's the GDP share of tasks impacted by AI, Acemoglu is relying on this Elandu et al. Paper. GPTs are GPTs. He focuses on their automation index, and it's important to keep in mind that this is not the main index they use.
Yeah. I guess just some before, how does this incorporate the extensive margin automation? Because I would have thought that would depend on the parameter.
The row parameter?
How does this potent effect sort of methodology incorporated all the extensive margin?
So the point, this goes back to what Phil was saying about it being an approximation for small changes. So Holton's theorem actually says we don't care what the row parameter is to figure out this impact, but that's only going to be valid for small changes. And that was kind of the limitations about, does this apply to large shocks? And I think the numbers that Acemoglu gets suggest these changes are small, which makes it reasonable to use the Holton's approximation. But we're going to talk about how you could get larger numbers, in which case maybe the Holton approximation breaks down.
Seems to imply that we're thinking of this as labor automation, not sort of extensive margin automation.
In this case, it could be either one going through. It's really not actually differentiating between the 2.
But I would have thought that extensive margin automation means 100% sort of automation within that task.
Yes.
100% cost.
But it still costs money to keep using that.
But the cost saving paper is just these time costs. The ones that you'll cite are just going to be time costing, right?
I mean, I think it's fair if you want to think about it as just labor augmenting, you could, but you could also think about it as that task is itself broken up into smaller tasks, some of which are being automated, and it's going to go through the same way here, basically. Because, I mean, when you have this extensive margin automation, that means that it's cheaper to use the capital for the same level of productivity, so you're getting the same sort of productivity effects. Okay, so this Elandu et al. Paper, Acemoglu was focused on their automation index. It's important to keep in mind this is not their main index that they report in the body of the paper. The main index in the body of the paper is what's called an overall exposure index. That overall exposure index is premised on questions where you're asking in a given set of ONET tasks, could AI do this 50% cheaper or 50% more productively than a human Obviously, 50% is a big threshold, which is why Acemoglu instead focuses on the automation index, which is just asking, can AI do this task? However, I think the way he uses it isn't exactly correct. So as Eric mentioned yesterday, the ONET database categorizes a bunch of different occupations into a bunch of different tasks. What Alondu and all do is they feed into GPT-4 what those task description are and ask GPT-4 to say to what extent an LLM plus, which is an LLM with software on top. And software on top you can think of as kind of like existing wrapper technology that builds in multimodal capacities, but not like too beyond what an LLM can do. And you're asking if that technology could automate the task. And then there's 5 different responses, which they code as T0 to T4, no automation exposure to full automation exposure. And they do quantify this. So no automation exposure is like 0%. T1 is 0 to 50% of the components of the task. Again, thinking about like subtasks. T2 is 50 to 90%, T3 is 90 to 100, and T4 is full automation exposure. So they index that as 0, 0.25, 0.5, 0.751. I don't know if this was just an oversight on Acemoglu's part, but he takes those decimals as the fraction of activities impacted by LLM plus, but that's wrong. Like 0.75 on the T3, this is 90 to 100% of the components being able to be automated. So there's already this slight discrepancy being introduced. Same for T2 being 50 to 90%, but being coded as 0.5. Phil?
Yeah, so another funny thing about those codes that I learned from talking to Pamela on that call, which I sort of mentioned the other day, is that apparently from her perspective, when crafting the prompt, in which they asked GPT-4, what fraction of the task could be of like the subtask could be automated, and putting in numbers 90 to 100% and so on. With that, the only reason she says you can think that actually like GPT-4 is trustworthy with respect to those prompts, but she said the only reason she put in the numbers was to get it to spit out something that was ordinally consistent, where like everything that was every time it said that a task had at least 50% of its subtasks automatable, or like at least 50% time saving. It also said could be like at least 25% of the time could be saved. Otherwise, it would give answers that like didn't rank consistently in that way. And she pretty emphatically said it's not just that like Acemoglu or whoever should be assigning different numbers to the T levels, but that actually, as far as she was concerned, there was no cardinal information in the T levels.
Interesting. Did not know that.
There was no what?
Cardinal information in the T levels. Yeah, and then I was going to say that so in his paper, he only considers as this measure of like GDP exposure the tasks with a score of 0.75 or 1. So this is pretty stringent because it's only the tasks that, ignoring this cardinality exception, that 90% plus of the subtasks could be automated with him. And then task exposures, yep.
We try several times to give us different answers.
So yeah, there's a slide about that. We have one slide evaluating automatability section. The answer is, it is sensitive to the way you prompt it, and it's sensitive across model generations as well. It's not, there's not no correlation, but it's not at all a perfect correlation. So that's a serious issue.
Maybe sort of 0.5 or 1, something like if the AI can only do a small part of this, and off to the AI is like not going to be worth it.
I don't remember if he really even justifies it in that much depth. I think he kind of just says we're going to use this, but I would imagine the logic is something like that.
Is this specific LM that was in the prompt GPT-4 so asking specifically what could GPT-4 do?
No. So you're asking what could an LLM plus do, which is something like current LLMs at the time of GPT-4 with like wrapper technology on top.
In that exercise, are the terms automation and full automation, low automation are defined in a proper reasoning to allow the LLM to actually act on these things? Because maybe the few things that shakes up between the different LLM models. So of course, the term automation is probably not well defined within the LLM setup. If you've seen something like that, was that bigger pre-prompt made to actually bring these concepts more into play with the outputs we say?
Okay, yeah, I think that makes sense. And I mean, I agree, like automation is a fuzzy word. Yeah. I mean, I think there's lots of like reasons you could call into question any specific numbers that come from this. I don't know if that like should bias it downwards or upwards, but yeah. Okay, so then task exposures are converted to GDP shares by combining tasks into occupations and using those occupations share of total wages. The result is that 20% of US labor tasks, wage bill weighted, are exposed to AI. As a reminder from Phil's note that the wage share is not actually equal to the DOMAR weight, but we're going to act like it is. And then we need a further estimate of what fraction of these 20% that are automatable are profitably automated within 10 years. And Acemoglu uses this Svanberg et al. Estimate that 23% of computer vision tasks, which were automatable, would be cost effectively automatable, multiplies those numbers and gets 4.6%. The important thing to keep in mind here is this Svanberg et al. Paper was talking about A, just computer vision tasks, not even large language model tasks, and B, talking about at their current costs as of the writing of the paper. Obviously, reasonable to think LLM's cost profile might be different from computer vision tasks cost profile, and that the cost is falling over time. We'll have more to say about that in a few slides. Yeah.
So obviously one way could be to apply a Moore's law kind of thing,
Mhm.
how the costs decline, but like a more aggressive way could be to apply a OpenAI or like scaling law kind of.
Mhm.
What's your position on that?
So we're going to talk about using existing estimates of cost declines to get to it. My general position is if you're doing this sort of estimate on a 10-year horizon, we basically shouldn't think this is a constraint. Like, I think in Eric's presentation yesterday, he said they used 88% would be profitably automatable. I think anything 80 to 100%, if you're taking into account any of the trends and costs, seems reasonable. And I actually think the reasonable benchmark is just to say like 100%. Like figure out which tasks are automatable. We're probably going to be able to profitably automate them within 10 years. Obviously, that's not perfectly true, but I think that's a better benchmark.
What I didn't like there, you first assume you'll eventually make it profitable, some percent of tasks, and then you say, oh, now I'm gonna extrapolate or whatever to 10 years. It feels a little fuzzy, but I think you could microfine that at some scale and all. That's why I thought.
Yeah, I mean, so we are going to, like, skipping ahead, microfound it based on existing declines in computing costs, if that's what you mean. Yep.
So the exercise is for the current state of the AI technology.
Yes. I mean, it's this LLM plus, which is like maybe slightly beyond. But
Yeah. So given that, is the number small? Like
yeah, I mean, I think I don't want to say that Acemoglu is wrong about like given his assumptions, but I do think it's pretty easy to say, can we stretch those assumptions a bit, taking still like relatively the current state, but just extrapolating a bit, not to anything crazy, and get significantly different numbers.
Just assuming that we get to automate everything profitably automatable, I think works. If the primary barrier to automating was in fact the profitability, but if it was something more like political economy constraints or like, rent seeking somewhere, then you might want to reintroduce some of the same parameter, but not as a profitable thing, but
yeah, no, I think that's a good point. And we're not going to talk about that today. We'll talk about that later in the course, but that's not here. No more question. Yeah, Maxine.
it's actually
it's hard for me to understand why you would have tasks that can be automated to some degree, right? Like, isn't the point of tasks to kind of write it in a way where they can only be automated if not automated, right?
Yeah.
So like 90% of components, why not, call the components tasks, right?
Yeah, I mean, I think, again, as Eric was talking about yesterday, they're developing, a much more finer grained task classification than ONET. I don't think we should think of these ONET tasks as like, the atoms of tasks. So therefore, it's meaningful to talk about 50% of an ONET task being automatable, but there's some level at which the task model we actually should have the perfect substitutes thing, and you only use one or the other.
Do you have an example of an ONET task?
I don't have one in this slide deck. I mean, Eric had those descriptions yesterday in his presentation. Yeah. So.
Yeah, I mean, just something that might make them feel a bit more tangible to us is, if I recall, being an economist, that occupation in ONET comes with 11 tasks, or at least, as of whatever year this data set is coming from. And, so yeah, it's just a reminder of how complex the world is, like 18 or 19,000 tasks total, and everything that you do in your day is coarsely cut up into 11, of which one is do research in economics, and one is do teaching of economics, and one is advise policymakers on economics. Yeah, once you see the list and the descriptions, the idea that there are subtasks starts people believing.
Thanks, Paul. So yeah, the final estimate through this procedure that Acemoglu gets is 4.6% is the GDP share of tasks impacted by AI within 10 years, assuming something relatively like AI at the time of the writing. Then to get the average cost savings or the productivity improvement, he focuses on 3 experimental studies. One is this Noy and Zhang paper, which used ChatGPT 3.5 for white-collar writing tasks. And whenever I'm talking about these studies, I'm going to try and mention explicitly which model was used, because I think when you're reading these studies, that's obviously like an important piece of data to keep track of if you believe that the models are getting better. So this Noy and Zhang paper was white-collar writing tasks. It was all like college-educated professionals across a fairly wide range of professions within white-collar writing. And they were given these tasks. They ended up having 40% faster completion of the tasks, and based on unbiased independent graders, there was an 18% quality rise. The note about actually there is Acemoglu basically uses the 40% faster completion as the productivity gains, completely ignoring the quality rise. There's 2 things to mention there. One is that actually in the paper, they report 37% faster, and Acemoglu just seems to round it up. Not that that's a big deal. But the quality rise, it's a bit hard to know how to translate that into productivity, because they're not measuring like actual earnings. It's just grading on some point scale. I think it's out of 7 or something. Naively, you could say, okay, 1.37 times 1.18, that means you actually have 60% productivity gains, which is bigger than 40%, but just something to keep in mind. The next study he uses is the Brynjolfsson and all one, which Eric talked about yesterday, where they were using these custom generative AI in a customer service setting. That study was used with 2021 large language models, so really not even close to state of the art. Acemoglu uses their number of 14% faster task resolution as the cost savings. It is 15% in the latest version, I'm just being nitpicky. And then the third one, which he doesn't actually use in his main estimate, but he talks about, is this Peng and all study. And this is freelance coders on Upwork given a specific coding tasks. And in the RCT, where some of them get to use GitHub Copilot, they complete the task 56% faster. So what Acemoglu does is he says, I'm going to average the Brynjolfsson and all and the Noy and Zhang one to get an average labor cost savings of 27%. And I think the reason for not using the Peng and all one in the main estimate is that maybe like software engineering is like really particularly different from other sorts of tasks. But I don't know if that's reasonable. So then to get total cost savings, you just have to adjust for the labor share, because this is just how much you're saving on the labor dimension, but there's still, that's only 57% of costs in BEA data. So then the average total cost savings is this 27% times 57%, which is 15.4%. And then using the Holton's theorem formula, we get that 4.6% exposed, 15% cost savings gives us a total TFP impact over 10 years of 0.7%, which is, roughly 0.07% increase in TFP growth per annum if we were to just say it's the same amount of increase every year of those 10 years. If you include the Panganol numbers, then that moves up to 0.94% over 10 years. So it makes a little bit of a difference, but not a huge difference. Acemoglu also has this exercise where he adjusts for which tasks exposed to AI are hard tasks that will experience lower productivity gains. That moves the number down to 0.55%. Not worth sweating that too much. We're going to move on to more discussion of this same framework. I will say that, there's a lot of other interesting stuff in that paper about the impacts on wages of low-skilled versus high-skilled workers across these scenarios. We're not going to talk about that right now, but it is worth looking into if you're curious. Cool. So then there's this Aghion and Bunel paper, which is basically them saying, we like using the Holton's framework, but we want to give our own estimates based on our read of the existing empirical literature because they think Acemoglu's are too conservative. For the share of tasks exposed to AI, they cite this Pisanelli et al. Paper as justifying 60%. I've tried to double check this a few times to make sure I'm not being an idiot, but I'm pretty sure this is just completely wrong for them to use this Pisanelli paper, because the Pisanelli et al. 60% number, which is in the US, is based on the relative exposure in the US versus the entire world. So they're saying that you have this automation, a different automation index from Alandu et al., this Felton et al. Automation index. And they're saying in the US, 60% of tasks are above the worldwide median of task exposure, which is obviously not just a raw measure of task exposure. If anyone else wants to look into it, I'd be curious, but basically I don't think you should count the 60%, but that's how they use it. Yeah, I mean, I think roughly people would say that from 1995 to 2005, TFP was about 0.5 percentage points higher per year due to the internet, like uncertainty around that. So he's saying something like an order of magnitude less, which is very small. Yeah.
3% of jobs in America is heavily weighted by license, right? I think yesterday, we had looked at radio mergers. It's just an example. Well, they're regulated federally and state, right? So even though most of the jobs can be automated, probably not actually exposed to AI due to political constraints, right?
Yeah. So I don't really think they're picking up on the political econ constraints that much. I think the simplest reason you would think that there's more exposure in the US relative to the world average is just there's more white collar tasks. Like, if you're comparing to the tasks in India, more of the tasks in India are going to be agricultural physical labor tasks that are clearly not automatable. So I think it makes sense that the US would have higher exposure, but maybe the political economy changes that. Maxine?
Maybe another one is like related to the versions of, like they always use kind of some ChatGPT version, right? And it would be, do you know how fast those shares progress? Because like, sure, we can do an estimate for ChatGPT 3.5, but if the gain in 1 year was already that big, then maybe, like that's not really relevant.
So you're just saying we should try and adjust the exposure for how fast it's changing over time?
Yeah. Do you know how it sort of the different models?
Yeah, so we're gonna look at that in this slide. which is thanks to Bharat. I didn't make this slide. And this is showing across different, tell me if I get this wrong.
Yeah, sorry. So this was actually meant as an example of why it's difficult to design good prompts.
Yeah.
The reason, as you'll see, okay, so should I? Okay.
Yeah, you can explain it if you want.
Okay, so there are kind of like three broad points that I just wanted to quickly mention about what makes this kind of challenging. One, what we talked a little bit about yesterday is this point that Pamela Mishkin raised. So for example, if I need to write an email to Phil and ChatGPT is really good at writing that email, but then I can't have a conversation during the meeting because I don't know what I'm talking about. So that matters both from like the theoretical point about, as Phil discussed yesterday, but I think there's also an implementation issue with that because I think an interesting question here is how you define what a task is, like at what level of aggregation. So for example, if there are these dependencies, you might want to consider a higher level of aggregation, such as occupation. And maybe you think about doing this kind of analysis at the occupation level instead of the individual ONA task level. So that's just a conceptual point that's like related, but not exactly the same as what Phil mentioned yesterday. Another thing is, I think Arjun is going to talk about this later as well, and he probably will do a much better job of this, but it is a little bit hard to design good prompts that work in the way that you want. So for example, Phil and I are working on a project where one of the things that we want to do was kind of create this time machine of AI exposure or automation exposure where we compare the capabilities in say like 2015 each year up until 2025 and maybe even do a projection into the future. Now, here is what like a first pass that I took at that.
It's not clear. I didn't hear you say it. When you say compare, what you mean is just basically redoing the Alonzo et al. Methodology of using a model to ask.
Yeah.
What could the best model
In year, yeah.
2021
right.
do? And it's not that we're not using models from that year in any sort of experiment.
Right.
Right? Because the model answering the question, we just want the best model that you've got. So we're using the latest model.
Yeah.
And we're asking it what could a model do in year N, which in principle is no less fake than like asking it what the best models in this year can do.
Yeah.
Right? Asking about the future is going to be more tenuous. But even asking it about the past runs into difficulty.
Yeah. So again, this was just like a first pass that I took at it, but I just wanted to highlight an issue that came up. The green ones here are like least exposed, the red ones are most exposed, and the yellow ones are in between. And you run into like this non-linearisticity. So for example, this task went from green to red back to yellow, which doesn't make sense, obviously. So you have to be like a little careful about how you design these prompts. And when we spoke to Pamela, she was saying that there was a lot of guidance, like human feedback that they were doing to make sure that the prompt produced things that made sense and were so like similar to the things that a human would classify. So you do have to handhold the models a lot. And I think an implication of that is a lot of what's my impression of kind of what happens here is like you ask the model, it gives you a result. If it doesn't like fit your priors, you like change the prompt so that it produces a result that better fits your priors. So there's a little bit of like alchemy going on here. But some people are I do think that there's like a possibility of doing this in a better way, but there's a little bit of this where you're just kind of redesigning the prompt so that it matches things that you think it's going to produce. So the other thing I want to mention is that so far, at least, there hasn't been a lot of validation on whether these things correlate with real economic outcomes. One maybe exception to that is this recent paper that was studying Microsoft Copilot usage and then correlating it with the Yolanda et al. Measures. And they actually did find a very strong correlation. So there's a 91% correlation between Microsoft Copilot usage and the predictions from the Yolanda et al. Paper. That's a little bit circular because they're like also asking the Copilot to classify the tasks. And so it's like comparing the Copilot classification of how people are using it with the predictions from Alondu et al., which was also produced by an LLM, but you know, and then I'll have more to say about this later. I think one maybe issue is that there isn't a lot of validation on how these measures like correlate with real economic outcomes. I'll have some stuff to say about employment later, but yeah, I guess stay tuned for that. Yeah.
I'm curious, my intuition would be, I would want to do that with a bunch of different LLMs and then probably average them out, or like try to work the same index and then average them out in the hopes that whatever like little error that one LLM does gets canceled by the other one, whatever. Like, do people do that at all?
Yeah, so in my view, I think the issue is not which LLM is producing the estimate. I think the issue is more in the specificity of what you're actually asking it to do in the prompt. So I view that as like a greater source of variation in what's going to happen than which LLM you're asking. So for example, if I like write the prompt in a certain way versus another way, that could have a meaningful effect on what numbers I'm getting out of this.
And on the point of validation, I'll talk about it more in a second, but we have a figure from Joseph Levine here showing the correlation between Acemoglu's predicted exposure measure and actual usage from the Anthropic Economic Index, which, you know, shows that it's pretty noisy, but correlated. Also, if someone else can correct me if they know more about this, but I'm pretty sure in the Bick, Blandin, and Dimming paper, which we're going to talk about in a second, which is a survey of AI use in the US, they report a pretty high correlation between the people in their survey in jobs who are using AI and the Alondu and all exposure measures. So I think they have been somewhat validated, but like subject to all those great caveats. And I know that doesn't really answer your question, Maxime. I don't think I actually know the answer to your question completely.
Sorry, if I could just add one thing about that. So another issue is that even if you do this validation and you like tie it to how people are using it in practice, I think there's a separate issue, which even if you do that, there's a challenge where you're trying to estimate structural parameters, for example, in this Holmes theorem framework. It's not obvious like how like the mapping between the empirical estimate and the structural parameter that you're wanting to estimate is like not that clear. So I do think that's another issue. Like you're trying to estimate a specific number, and there's not a clear mapping between what these longitudinal things are measuring, and that's not really
like the light augmented technology.
Yeah,
is the thing you want, and or the TFP number if you know the factor shares by task or by application. And yeah, you're not asking it about augmenting technology per se, but we ask. Great. Unless, yeah, you probably won't use those words in the prompt, or if you do, you'll get some bizarre response, and so you'll tweak the prompt so that it no longer reads like the economically relevant question. Yeah.
Bunch of other questions, yeah.
Is there also like any attempt to actually just like ask humans like about this constructing disease with humans, and how do they compare with the LLMs?
Yeah. So I think Eric mentioned this briefly yesterday. Like there was an earlier version. I mean, it's not the same paper, but there was an earlier effort by a bunch of the same co-authors on the Alondu and all paper where they did it with just humans. And then in the Alondu and all paper for like a subset, they validate it with humans. And I'm pretty sure they get pretty high correlations between the two. But again,
they take the prompt.
Yeah.
But the thing is, given that the exercise of the productivity index at the current state of technology, like the comparison compared to the internet, the comparison would be more like the productivity index of the internet if it stays at right 128 kilobits per second forever.
Yeah.
And so what I'm wondering is that I guess beyond just like different aesthetic ways to do this exercise, one thing that would be interesting would be like someone did this exercise, right? ChatGPT 1 and then different version, next version.
Yeah, so I think this is similar to Maxime's question, and we're going to talk about that like a little bit in just the next few slides, but I agree there's like more room to extend that. And there's even next week, we have like one more slide that's kind of using this exact framework, but taking trends in performance over time seriously.
Sorry, we keep getting hung up, but it would have seemed to me that your question is totally answered, or like what you're proposing doing is exactly what Bharat threw up there. That table where you kind of have, you know.
Yeah, but then what is the trend in the?
Yeah, what Bharat said is that, it's hard to get an answer. No one's figured out a way to get a reliable answer to that question. We all want an answer to that question. So the problem is that when you try to replicate their methodology year by year, model by model, you don't even get a monotonic trend, right? So that's clearly wrong. So if you figure out a way to do it so that's kind of sensible, reliable seeming, then
Well, sorry.
I do think Arjun.
Yeah, so we have monotonicity on this. Basically use the model cards from all the papers. So,
Okay, great,
so then
great.
rather than ask GPT to know, hey, GPT, please be good at task. You take the model card, you take the summarized version of it, you put it in the I'm gonna do it all rubric, and you get somewhat sensible results. You can judge for yourself in an hour.
Yeah. I do want to clarify that you like can write a good prompt, and I'm sure they did. I'm just saying, like, you do have to think about it.
And I mean, there's three dimensions here. There's like exposure, profitability of automating, and cost savings. And what I'm about to talk about is how the chance of it being profitable changes when you take into account trends. And this Ali Morali paper, which we're going to mention a bit briefly later, it gives like a scaling law for how much productivity is increasing on specific translation tasks across models. And then he does this same sort of Acemoglu exercise and gets that if you tinker with the exposure numbers a bit and take into account that you're getting 16, I believe it's 16% more productive across an order of magnitude of scaling in this translation task, then the Acemoglu number becomes 8% instead of 0.7% over 10 years impact. So yeah, on this point, for the share of tasks profitably automated, Aghion and Bunel note that the Sandberg and all estimate is based on current costs. If costs decline 20% per year, 50% of tasks will be profitably automatable in 10 years. There's a figure showing that. So this is in the actual Sandberg and all paper. Like Acemoglu says, okay, we're going to consider this point. But Sandberg and all are pretty explicit about the fact that if you have cost decreases, you get a much higher share profitably automatable on a short time scale. And then what Aghion and Bunel say is, okay, we're going to use 50% as the share automatable, given this Besaroglu and Hubhand estimate that there's 22% annual declines in computing costs, though the more recent estimates from Epoch are 30%, so I'll tinker with it slightly. And then Aghion and Bunel, instead of averaging Nguyen-Zhang and Brynjolfsson, they just say Nguyen-Zhang is the median of Brynjolfsson and Panganol, so we're going to use 40% cost savings. Then just using this method, you get that it's a 6.84% TFP increase over 10 years, so almost an order of magnitude larger. And this isn't a huge number, but it would be a very meaningful gain in TFP growth, like relative to the 2010 to 2024 baseline TFP growth. This would be an 80% increase. Here's kind of like my own slightly preferred way of doing it. I don't think the 60% share of tasks is supported for the reasons I gave. But you could say, okay, we're going to take the Landau and all classification seriously again, and we're going to factor in these T2 and T1 tasks that are partially automatable. If you just do that out, it implies another 32% of wages that are exposed to AI. Furthermore, the Aghion and Bunel estimate for the share profitably automatable is only taking into account declines in hardware costs over time, or gains in hardware efficiency that lead to computing cost decline. If you also factor in algorithmic improvement, which we think is making the fixed cost of compute required to achieve, or the cost of compute, the amount of compute required to achieve a fixed quality performance declining at 3x per year, it's easy to get 80 to 100% of exposed tasks would be profitably automated. There is a caveat that if these costs are falling, that also means that in the tasks you've already automated, you're getting more and more cost savings, but you're getting not that more and more cost savings on the newly automated tasks. You could think about that as like roughly washing out. So, say we still assume average labor cost savings are at 27%. If we take the previous Acemoglu number of 20% of wages exposed to AI, add this 32%, so we have 52% exposed, 100% profitably automatable, use this number, then you get 8% TFP increase over 10 years. So the point of all that is, again, not that we should take these numbers super seriously, but just it's very, I think, plausible to get an order of magnitude larger estimates. You don't have to make any crazy assumptions about the trajectory of AI. This was Bharat's slide. I've got, 13 minutes before Arjun's supposed to come on. So this is going to be just kind of a quick tour of like a bunch of different evidence on the current impacts of AI on, how much people are using it, labor markets, productivity, et cetera. I've cited what I think are kind of the most important papers here, but there's a lot of work I haven't cited. And if someone thinks something's particularly important, feel free to shout it out. One thing to be aware of is this Anthropic Economic Index. They're now periodically releasing data on how Claude, and now in their most recent update, Claude Code are used. And they map user conversations to tasks in the ONET database, as well as their own bottom-up classifying across like a different task space that they've constructed themselves. They do this thing where they try to identify automation versus augmentation use cases. I don't think should be taken that seriously, but in case people are curious, they get that in current Claude usage, 43% is automation, 57% is augmentation. And in their data, they find that about 40% of ONET occupations see AI usage for at least 20% of that occupation's tasks. Only 4% see over 75% task coverage, and the figure shows you the distribution of what fraction of tasks are in use for a given fraction of occupations. Yeah, Maxine.
The point of those papers is basically to present a bound, right, on how much you can have on productivity gains and employment effects, right?
You're talking about the Acemoglu and Aghion and Brunel papers?
In general, the papers we've seen in there, because like obviously they don't talk about adoption, right? It's health.
Yeah. So this is kind of like a shift in the presentation. We were talking about estimates of the TFP impacts. Now I'm just going to go through evidence of adoption and its impacts to give you more context. And then Joseph Levine, who's here, did the fun exercise of looking at the Anthropic Economic Index data and figuring out what percent of wage-weighted tasks are being used in these Claude conversations. It turns out it's 23.7%, but that just means 23% of wage-weighted tasks someone has used Claude for at least 15 times. That doesn't mean like 23.7% are being used for Claude all the time. You could interpret that as the share of tasks which are profitably automatable and get a much larger penetration than Acemoglu's 4.6%. But as the bullet makes clear, that would require assuming 100% of the task is done by Claude and that it's profitably automatable. I'm not sure we should think that. And then this is the figure I mentioned earlier, comparing Claude usage with Acemoglu's scoring of Elandu and all exposure. So it's not Elandu and all's actual data, it's the way Acemoglu codes it, and you see that it's pretty noisy, but correlated. Do you have a question?
Yeah, the index have both the consumer facing and the API stuff, or only one do?
It's the first release was just the consumer facing stuff. Now they also have Claude Code in there, but they still don't have like the business API usage, I believe.
By 15 times, what does that mean? You've had 15 chats with users? Or?
Yeah, so it just means there's been 15 times that in this data, there was a conversation with Claude where when you ask Anthropic's own, it's like a wrapper around Claude that they've developed where it then looks at the conversations and says, which tasks in the ONET database does this apply to? So at least 15 times you had that wrapper categorize that conversation as pertaining to that task. It's a lot. I don't remember the number. 1 million. Thank you, Joseph.
was consistent?
No, and I actually asked someone about that, and they said they were planning to release more on that, but they haven't yet, as far as I know. Yeah. Continuing to go through it. So I mentioned earlier this Bick, Blandin, and Deming study. This was a fall 2024 survey of Gen AI usage in the US. And they like rolled it into this already existing online survey platform. Their finding is that, they have a lot of findings. It's a great paper. 9% of workers use Gen AI every day at work. 22% used it at least once in the previous week. And that's just at work. If you expand it to just people who used it in general, I think the number goes up to like 39% used it in the previous week or have used it. Among those who report using it at all, they self-report. So this is just people in the survey being asked how much time they're saving. They self-report 5.4% time savings. That's like 5.4% of their work week that, their work week was how many hours they had to do their work was 5.4% less. That doesn't mean that's the productivity impact. To get the productivity impact, you also have to account for how many hours are they actually using it. They do the estimate that implies 33% time savings per hour using AI, which like nicely kind of lines up with some of the other estimates of productivity impacts we've seen. This implies that if you aggregate across, the survey and the occupations and do the weighting in terms of how representative they are of the US, you get that 1 to 5% of all work hours are already being assisted by AI in fall 2024. And this implies aggregate 1.4% time savings and a 1.1% boost to TFP already. The reason maybe you don't notice this, but it might seem like that's a large boost to TFP relative to the time savings. The biggest reason for that is that it's more weighted on high wage occupations. And so to get the TFP number, you have to weight by, how important those time savings are relative to how much of wages those occupations represent. It's disproportionately being used in higher wage occupations, so you get that. And again, I think it's worth remembering, like, this is like it's self-reported surveys on the productivity gains, but they're implying that by fall 2024, Asamogu's main estimate of the 10-year impacts was already undershooting. Yeah, I think that's interesting. There's this other paper, Humlum and Vestergaard. They have like really great data where they surveyed 25,000 Danish workers in exposed occupations, fall 2023 and 2024. They find a bit lower time savings than the Bick Blandin paper, 2.8% for users, but no significant effects on the earnings. They're able to link their data to labor market outcomes. Interestingly, I think one thing to flag from there is they have this stat that AI chatbots have created new job tasks for 8.4% of workers. And if you remember when we were doing this Holton's approximation, we were ignoring the new task dimension. But if AI chatbots have already created new job tasks for 8.4% of workers, you might think this is going to be a very important dimension to keep track of. More just throwing data at you. There's this Liang et al. Paper, which shows as of September 2024, 18% of financial consumer complaints, 24% of press releases, 15% of job postings, and 14% of UN press releases showed signs of LLM writing. And this Kobach et al. Paper that says 14% of 2024 biomedical research abstracts used LLMs. Some of you might have seen this figure before, but I think it's kind of fun. This is from the Kobach et al. Paper on biomedical abstracts. You see that DELVs in particular just shoots up in frequency. And all of these words are words that have clear trend breaks suggesting LLMs are being used in the writing of the abstracts. Yeah.
But note that there's now evidence that people are using the word elves.
Yes.
Like it's socializing with AI.
Yes. Yeah. I read Delves in a blog post the other day where it was like surely written by a human, and it was like, oh. There's this Daniotti et al. Paper where they look at GitHub Python commits and use a difference in difference strategy around model releases. They find that by December 2024, AI wrote 30% of functions in the US of US GitHub Python commits. The rate is a bit lower, 11 to 24% in other countries. And they do this within developer fixed effects regression exercise to estimate that moving to 30% AI use raises quarterly commits by 2.4%. They also then translate that into aggregate cost savings or like impact in software engineering. And it comes out to about like 5% of software engineering wages paid out in the US already, which interestingly large. And then finally, there's this Hartley et al. Survey, which is very similar to the Bick, Blandin, and Dimming survey. They, in some cases, use the exact same questions, but theirs is more recent. Their data goes to as recently as July, like a month ago. And they find that 46% of workers report using generative AI for their job for, on average, 1/3 of their work tasks. That's like a lot of usage. Just something to be aware of. This is the Daniotti et al. Figure on Python commits over time. You see that pretty clearly around the Copilot release and the ChatGPT release, there's an upward trend. They're using a statistical method to identify which code has had LLM or Copilot writing assistance. It's probably not perfect, but seems to capture something. And then this is the Hartley et al. Survey juxtaposed with other surveys over time. And you see that there's a pretty clear upward trend in this fraction of the US labor force using generative AI at work. There was these early Pew surveys, which indicated not much adoption. There's the Bick, Blandin, and Dimming survey, and then there's the rounds of the Hartley survey since.
That's the once a week number, right?
I think
Daily.
no, it's not. It's definitely not daily. I think it's so. One thing I'll say here is that my annoyance with the Hartley et al. Paper is on all of their figures, they don't actually put what the exact question is that it's representing. I believe it's like used it at least once in the past 2 weeks, but they don't actually put it explicitly. So I'm like a bit unsure. More studies on just the productivity impacts. How much time do I have? Okay, I'm going to go very fast through this stuff. There's the Schwartz et al. Experiment, which studies upper-level law students completing 6 legal tasks. They show an average 71% increase in productivity when given access to ChatGPT o1 Preview. This is one of the few studies that uses a reasoning model, and they find much lower productivity impacts when those same people are using GPT-4 as opposed to o1 Preview. So I think that's an important data point. One thing is that of those 6 legal tasks, they measure both quality and speed. They always get speed gains on quality for one of the 6 tasks. They get a fall in quality, but on 5 of the 6 tasks, they get an increase in quality. There's this Dell'Acqua et al. Experiment with BCG consultants. They find that for tasks within the frontier of AI capabilities, speed increased 25%, quality 40%, but performance was harmed on tasks outside the scope of capabilities. And they then talk about this notion of the jagged frontier of AI capabilities, which Arjun's going to talk about more in a bit. Within the frontier of AI capabilities task there is like coming up with a new product and how you would introduce it, while the outside the frontier is given information about a business, like spreadsheets and interviews with customers. You have to pick which of the business's brands should be promoted more, and there's a correct and incorrect answer. So interestingly, on like the softer task of just being creative, the AI increases productivity, but on the hard task where there's a right and wrong answer, the AI actually hurt productivity. That same Hartley et al. Survey we talked about earlier finds a self-reported 3x productivity increase, which is huge. But there's going to be a caveat about that in a second. This Morali paper that I mentioned looks at different orders of magnitude of model compute in language translation tasks and finds that adding an order of magnitude of model compute leads to 16% productivity gains for translators. There's this Paradis et al. RCT of 96 full-time Google software engineers finding 21% productivity boost from AI. And there's this Becker meter study, which I believe Eric mentioned yesterday. They run an RCT on 16 experienced open source developers. They find an average negative 19% productivity impact from using AI, despite self-report estimates of 20% productivity gains. And there's been lots of debate about the meter study and how applicable the negative number is to like our general thinking about AI productivity impacts. I think it's reasonable to interpret it as something like maybe in certain very high context tasks with relative experts in those tasks performing them. Right now, AI is not helpful and could be actively harmful. But I think maybe the bigger important takeaway is when we're looking at something like the Hartley self-report, we should really discount that because there's clearly a gap in people's perceptions of the productivity increases and how much productivity increases are actually occurring. This is the figure from the meter study with the same point. This is the meter study compared to other studies. You know, they want to say, oh, like, look, we hit all these check boxes, so therefore you should take us more seriously, maybe. But another way of looking at it is like, well, they're the outlier here, so maybe we should discount accordingly. On labor market impacts, Bharat's going to say a lot more later. I'll just flag that there are these studies of like what's happening on freelancing job sites, and I think there is pretty good evidence that there has been declines in job postings for the sorts of tasks you would think are super exposed to LLMs, but some increases for complementary jobs. The Humlum and Vestergaard study of Danish workers finds pretty robustly no impact on work hours or earnings for their Danish workers. An earlier study of Bharat's finds that occupations most exposed to AI on average show no substantial difference in employment or earnings growth compared to the least exposed. Should say more to come this afternoon, but there's a change in the timing. There's more to come on that. And corporate usage, there's the Census Business Trends and Outlook survey, which collected survey responses on AI usage for 165,000 firms in fall 2023 and spring 2024. They get much lower numbers relative to the consumer surveys. You might think that's because the business isn't actually paying for the AI service while a consumer, like the worker at the firm, is just using it on their own time. But it also might be due to the fact that the survey was a bit earlier in time. By contrast, RAMP has corporate credit card data on 40,000 companies. They get that 43% of firms are already paying for AI tools of some sort. I don't think this RAMP data is... they're not as detailed about their methodology as I would like them to be. It's not clear to me that they're correctly weighting their sample for like representativeness of the US firm sample. So I don't think we should take their data at face value, but it is something to be aware of.
They're not reading it. And it's also just probably biased by their particular user base.
Yeah.
Rather than forward early adopter base.
Yeah, thank you.
But also, like, if they're using a particular kind of software that suddenly has like AI, does that also get into their calculations? Like, let's say, like, if I feel like.
Are you talking about the RAMP data?
Yeah, I remember when Copilot came up for Word. Like suddenly you have an update and then there's like an AI tool.
Yeah, so I mean, what they're looking at is like corporate credit cards being billed to external businesses and then figuring out, does that external business count as an AI business? I don't know if like, you know, the moment Copilot is introduced into Word, if you've paid for Office previously, they're going to count that. I agree that could be tricky, but probably they pick up on some of that sort of stuff. Should I skip Jones and Tonetti?
Yeah.
Okay. Well, yeah. Jones and Tonetti have a cool paper. You should look at the slides. They basically figure out how much automation has contributed to growth historically. The headline takeaway, and like it is important to understand the methodology, but the headline takeaway, maybe, I mean, there's multiple interesting takeaways, but one is there was no automation since 1950. Aggregate TFP today would be 22% lower. They have case studies on agriculture, motor vehicles, and software. They break it into labor quality and task quality. And then they also project forward, making the point that if you just fully automate one small sector with infinite productivity, you don't actually get that much gains because of complementarity. And now we'll take a 10-minute break and have Arjun afterwards.
Thank you. Joe, Teddy out, or did that basically slide?
Hey guys, this is work in progress with Eric and Basil. It's very preliminary and many of these slides were made in the last 2 days, so apologies for typos. Comments very welcome. This is a project on the economic implications of the multidimensional intelligence hypothesis. In a way, one reading of this is sort of pushing back on the notion of a single notion of artificial intelligence or artificial general intelligence. I'll have a pretty extended motivation, so just bear with me because I think that's important for fixing ideas. And then we'll get into some of the empirics, talking about some of the methods around this time machine chart and dimensions of intelligence. So context. Sam Altman recently wrote a blog post where he talks about the cost of intelligence. Dario Amodei also has an essay from last year where he talks about the marginal returns to intelligence. And there's Leopold's famous essay where he has the line go up and to the right, where model progress leads to increasingly better outcomes in relation to humans. And I think the common strand for all three of these examples is this sort of implicit model where there's a single notion of intelligence as capabilities progress. So, there's really only one dimension to intelligence. And it turns out, we shouldn't, beat up on these people too much, because sort of economists oftentimes do the same thing. In our baseline task model that we learned yesterday, there's a single dimension of tasks on that tasks are ordered on, and automation or technological progress is modeled as shifting that boundary, that marginal task on that single scale. And in Anton Kornack and Dongin Shu's recent paper, economic scenarios for artificial general intelligence, they also have a ladder of task complexity that automation is moving up on. And so you can see in this nice GIF, which I'm pleasantly surprised is loading properly, tasks are getting better over time. And we're going to sort of bring forward an alternative way of thinking about this, where if you have a frontier with two dimensions of tasks, so cognitive tasks on the x-axis, physical complexity on the right axis, and you can think of this as a point on this frontier. If you're inside the frontier, then you can do it, whether it's a human or a model. If you're outside the frontier, then you're not able to do it. It's outside your intelligence frontier. Think of the blue frontier as humans, and then think of the red frontier as artificial intelligence getting progressively better over time. And the point here is it's uneven, right? It's getting better faster at cognitive tasks than physical tasks. And that's sort of the notion of jaggedness that we think is very important and descriptively realistic. And importantly, once you get to the end of the GIF, right, it's better at cognitive tasks, but still remains worse at physical tasks. And I think that's what we're going to sort of emphasize in this presentation, is the evolution of artificial intelligence progress over time is actually accentuating its jaggedness, which maybe, you might not think that has to be true. You might think that progress actually reverses things, and you get to uniformity over time. So that's one way of thinking about it. Here's a second way of thinking about it to motivate this project. Again, think of the x-axis as cognitive intelligence, the y-axis as physical, just two dimensions of intelligence. And each point is like a human, all of you guys. But actually think of it as a random sample. This is probably not what things look like, which would be randomly distributed over the space of possible intelligences. What it more likely looks like is something like this. These are not real data points. But if you were to do PCA, principal component analysis, the first principal component, according to some sketchy psychology research, suggests that you can explain 40 to 50% in the variation in performance on psychometric tests across humans through the first principal component. And a lot of people call this the G factor, or like the general intelligence factor. And that concept has been translated to the artificial general intelligence discourse. A lot of people think that as you increase model scale, you're just generally improving on all types of capabilities. And that's sort of the main thing that explains variation in capabilities is model scale. That might be true, but we still think multidimensional intelligence is important, because more likely than not, it seems, if you think about your casual usage of models and some of the studies we have, like Delacqua et al., the Jagged Frontier paper, it seems that models have a different first principle component than humans do. So, the two lines are not the same. And that's sort of what we're going to push forward in this project. Okay, final way of thinking about this, and then we'll get into the actual what we're doing. Let's bring in some economics. Again, we have a frontier of intelligence here, cognitive on the left, x-axis, physical on the y-axis. The green line is sort of your intelligence frontier. The red is your indifference curve. of consumers. And so your blue line, the line of tangency, gives you the relative price of the two types of intelligence. Now, suppose you introduce some technological progress that is jagged. So you get better at cognitive intelligence, but you don't get any better physical intelligence. Then the line rotates and your relative prices shift in the market for intelligence, whether you're buying from humans or from machines. And that's how we're gonna, when we end up in the later stages of the project, doing some simulations and building a quantitative model, that's sort of the idea that I think will connect the intelligence to the economics, to your wages and so forth. Yeah.
Need the physical intelligence here.
Yeah, it's like ability to do physical tasks. So like, manual dexterity, building a house, anything like that. Yeah. Sorry. What is the component? What do you mean? Or yeah.
Have the different ingredients to get this person. I want to.
Oh yeah, so you can think of this as like you're taking every human and you're grading their performance on a bunch of different tests, like a cognitive test and a physical test, and then each human is a point in that space, and then you're running PCA on those test scores across humans, across a lot of different humans, exactly. And then the psychologists tend to call this the first PCA, first principal component, G. Cool. So we've been here before where relative prices have shifted from technological change. You guys are probably familiar with this literature, but Otto Levy and Renee in 2003, computers substitute for routine cognitive tasks and routine manual tasks, and then complement non-routine tasks. And so you saw the occupational structure of the US labor market shift in response to this. You saw relative prices for labor shift. This happened during the first industrial revolution, where the machine operation of the power loom basically put out of work a lot of artisanal cotton workers. And actually, it's some pretty striking data in the Acemoglu and Johnson 2024 paper. In early 19th century, you see like pretty large drops in the wages and employment of people working in the power loom sector. But then you also saw the creation of entirely new classes of jobs that required different types of intelligence. Operating these machines, maintaining them, building them, etc. Okay, so just to state what we're the hypothesis very clearly, we're claiming intelligence has multiple dimensions, and humans and AI vary on these dimensions in terms of their capabilities, and also importantly for AI in the pathway of evolution. And so we're sort of trying to ask, can we provide a more explicit characterization of those dimensions? Like, what are they? How has historical progress changed the relative strengths and weaknesses of humans and AIs? And this is where we're going to get into that kind of time machine analysis. And the third part we're not going to get to today, but in the future, what are the economic implications of projecting this out into the future? Okay, empirics. So what do we need to do all of this? We need a measure of AI capabilities by task. We're going to use the Olundu et al. Measure, and then we're going to extend Olundu et al. To the past, to prior models. That's the main measure of capability. Dimensions of intelligence, what are we going to do? We're going to take the ONET database that we talked about earlier. We're going to use GPT, and we're going to grade all the ONET tasks on different dimensions. So for example, is this task, does it require physical presence or not? Is this task a long horizon task, or is it a short horizon task? Does it take years, or can it be done in days? And we're going to do that for a bunch of different dimensions. So yeah, ingredient 1, list of tasks, AI ability by task. Ingredient 2, list of dimensions and task score on each dimension. You can kind of see this in the table here. Suppose you had coding, writing emails, doing papers, and laundry. Is it a physical task or not? And then here are 2 other dimensions we think are pretty interesting and important. Does the task have output that's easy to verify, or is it difficult to verify? Is it a long horizon task or a short horizon task? And then the final column is the AI capability measure that's coming from Olundu, or the historical Olundu. Can this task be automated by a particular model or not? And then what are we going to do with that? Our goal is to make the sort of meter time horizon graph. Hopefully you've seen that before, but if not, the idea is that for a given dimension, say whether a task is long time horizon or short time horizon, what % of tasks in that category can be automated as AI progress continues. So maybe it's very little at first, And then for things that models can do for more recent generations, you can automate a lot of them, but perhaps for long time horizon tasks, maybe not so. Yeah.
Yeah, just because, maybe writing a paper is especially relevant to many in the room. Can you say more about why you would call that not verifiable output? It seems to me that we have, millions of examples, or at least, many thousands of examples, if you're thinking about a particular subdiscipline of papers out there, things that get no citations and sync without a trace, and things that get zillions that are published in top journals.
Totally.
Actually, both journal rank and citation count.
Yeah, so I totally agree with you. This is debatable. We're just gonna go with what GPT says for the exercise. I think that's probably, this, you could debate this. Yeah. And perhaps that should inform a different prompt. Yeah. Yeah, and this is a difficult question. I think you could argue that long horizon tasks are compositions of smaller short horizon tasks. They might also not be, right? We have, you learn in first year macro dynamic optimization. If you just run a greedy algorithm, you might get the wrong answer for a long horizon task. Totally agree. We're just going to trust GPT. So I think it's getting at something interesting, which is you could probably improve on all these measures. And to be clear, we haven't validated all of them. We've validated like some of them by hand. And also done like some of them where you have explicit measures like remote work. We validated, but totally can improve. Yeah.
What exactly is the length of tasks, like in minutes, hours? What?
Yeah, so I think we did like up till a day is short, up till a month is medium, and anything longer is long. But or sorry, no, we did less than a day is short, days is medium, and then weeks longer is long. But again, you can play with that. Yeah. Okay, cool. You might wonder, why not just use benchmarks to measure capabilities? Yeah, I don't think it really works. And actually, this is going to be, we talked about in the morning, is Acemoglu an overestimate or underestimate? I think the casual, most people think that it's an underestimate. I don't know. I think a major issue with all the studies is basically most of the productivity studies and all the benchmarks suffer from selection bias, is something I've talked about with Parker. If you can measure performance, then by definition, it's something it's easier to train a model to do, specifically with reinforcement learning by verifiable rewards. So it's very plausible to me that the things we're measuring performance on are the things that AI does best, and actually it's going to be a lot worse than everything else, in which case Acemoglu would be an overestimate. That's the reason why I think benchmarks don't really work for this exercise. To be clear, it's not like what we're doing is necessarily much better, but it's a reason not to take that out of the box. You also need to map things to economic quantities. That's the real reason to work with the ONET database, is because then we can say something about the actual composition of occupations. So just to be clear on our approach for measuring automation capability, we're using the same grading rubric as Alundu et al. We're just adapting it to different models. The way we're adapting it to different models is we're taking the model card, if it exists, or the technical report that came out with the OpenAI model. We're summarizing that and we're putting it into the prompt. So ideally, it's like a relatively replicable mechanical method that doesn't introduce too much researcher discretion into the approach. A lot more work can be done there. So as an example, here's our summarized model card for GPT-2. I took like specific portions for the slide. The thing I'll point you to is look at typical strengths, limitations, and ONET task fit. It's kind of like, it's good at short form writing, TLDR summarization, but it has very frequent hallucinations. But then if you look at O3, it tells you it's good at long horizon reasoning, explicit planning, excels at complex task and image tasks. So that's the content that's sort of driving the differences in capability in the automation exposure score across models. Yeah.
Yeah, out of curiosity, have you tried doing this with GPT-4 instead of like O3? Did you get different results?
Yeah. So that's this. Oh, you mean like comparing to Alundu? Or
No.
Great.
So
Sorry. Yeah.
First, when we spoke to her, was that she thought that the prompt that they designed was like pretty tailored to the way that GPT-4 was responding.
Yeah, we're using O4 Mini for all the grading for just to cut the price. Yeah.
She did say that like she wouldn't feel super comfortable like taking her prompt and then using it with a different model because she felt like it was tailored to the model that they were using. Anyway,
that's really useful to know. Then maybe we should just use O4. Yeah, cool. So what we're doing here is we're taking each model, we're taking the average score across all the tasks for that model, and we're just plotting it over time. So remember the scores, it goes from 0 to 4, the same thing we talked about earlier. And it's kind of reassuring that it's going up over time, and the biggest jump happens from 3.5 or 3 to 4. It's worth knowing that even O3 only gets you a little bit above 1. You're not getting anywhere close to 4. You can see the decomposition across the different ratings here. You'll notice that the T0, which is not able to automate at all, is going down over time. T3 is increasing over time. T4 is barely changing. So even O3, according to GPT-4, is not able to automate fully 100% of the time, basically any tasks. If you were to weight by the wage bill of occupations and then also look at the percentage of tasks that are highly automatable, so either T3 or 3.4, you get pretty strong upward increase monotonicity here. Yeah.
Right, can you just go back a slide?
Yeah.
So it seems like maybe we've mostly cut down on the monotonicity issue, but it still seems like it's saying that a higher fraction of tasks are in T0 or T1 for O3 than for O1.
That's true. Yeah, it's not, it doesn't go away. Yeah. Yeah.
Which is basically yeah.
Yeah, no, totally fair. Sorry. Yeah, no, I don't have an explanation for that. Yeah, no, that's totally fair. Got to prompt engineer more. Yeah.
Memory, I found that O3 takes a lot of time sometimes to get you back to answers. Like, does that matter for like this evaluation of progress?
Sorry, it takes a while for O3 to do stuff. Oh, it just like inference takes a while.
Yeah.
Yeah. We're not considering that. I mean, it's possible that when the model, like when GPT-4 is grading a task for full automation, it incorporates that. But we're not making that explicit. Though I guess in the model card it does say that it takes longer. So perhaps. Yeah.
So, like, I guess it seems like you guys give a like lower number for GPT-4 than the one who does for T3 and T4.
Lower number.
Like, I guess my memory was that you said 23%, is that?
It was 20% of wage weighted using.
Okay, so this is just like the non.
Yeah, it's not going to give the same number. I have the comparison to Lundu here, and we don't get the same numbers for a few reasons. One is because to use the same process across all the models, we're using the summarized version of the model card or the technical report, which is not exactly what they use for their prompt. So actually, I'm pleasantly surprised it's even like reasonably correlated. The other reason is because they're doing LLM++. We're just doing GPT-4. Yeah. Yeah.
What kind of role are like the models priors over the models? Instead of the
Yeah.
model card?
Yeah.
Now, when you did something like instead of saying that like this model is GPT-4,
Yeah.
you said this model is like model blue 03. So all the information that it had was in the model card.
That's a great idea. We should try that. I like that. Yeah. Yeah. Take out name. Cool. Okay. So validation, I'll skip most of this. Basically, it's reasonably correlated, but not entirely so. Wish I had more comparisons, but we don't. Okay, dimensions of intelligence. This is several ways to get at this. Basically, we talked about like time horizon. We talked about verifying outputs, whether a task is physical. Where did we get these dimensions from, right? They kind of dropped from the sky. So really, they came from the econ literature, like the dimensions that people thought were important, plus sort of like our priors over what's important, like output verifiability there isn't like a canonical econ paper I can point you to, but it seems pretty important for reinforcement learning. A few other ways you could generate dimensions if you wanted it to be exhaustive. We've tried GPT generating dimensions and using prompts, like telling the model, hey, come up with mutually exclusive, collectively exhaustive set of prompts. Dimensions. We've also tried doing PCA on ONet. Today, we're just going to look at priors from the literature. Here are the ones that we graded all the tasks on. You can see some of them come from papers, some of them don't. I think these three are the most interesting. For the purpose of today, we'll focus on them. Just to fix some ideas in what we're doing here, I just added this in literally during the break. Here are the ONet tasks for the role of economist. You can see the description. And then here are the scores that came from our dimension scoring exercise. 3 means it's harder for, it scores higher on that dimension. It's harder for the model to do. 1 is it's easier. It's going to take a while to go through all of this. So I'll just point you to that final column, manual, non-manual, where you basically score 1 or 2 on everything, which is reassuring because the role of economist, even though we're all in person right here, some people are on Zoom, it's not actually that essential compared to a lot of other jobs in the economy to use your hands or be in person. Anyway, I mentioned the 3 dimensions that we think are particularly important. Physical presence. The reason why is because this actually is a point of validation. We should expect to see very little progress over time on physical tasks compared to other types of tasks. And if we don't, that's a reason to believe this method is not really that useful. Time horizon. This is that famous meter time horizon task graph. You can see that models achieving 50% performance, it was able to do so only for like a couple second tasks during GPT-2. More recent models, it can do like hour-long tasks or more. And then the third thing that we think is interesting is output verifiability. And so this means, can you actually grade the performance of the model on a task, ideally in an automated fashion, because then you can do reinforcement learning. So here are the grades. We talked about output verification, time horizon, and manual work, which are on the right 3 tasks. Other 2 that I added here, cost of mistake and social skills. And you can sort of see what's interesting is GPT-4 at least thinks that a smaller percentage of tasks are really hard for AI on any of these dimensions, which is sort of interesting. But there's a lot of variation. Another point of validation. Suppose I aggregated the task level scores to the occupation level. Which occupations show up at the top? Which ones show at the bottom? So for output verifiability, if I were to take the task level scores and average them, and I've normalized these on a scale from 0 to 1, so 1 is the highest, it would be the hardest to verify. Actors, sales managers, they have a lot of hard to verify tasks. Things like in the manufacturing sector, like shoe machine operators, stonemasons, etc., it's much easier to verify. So this should just give you a little bit of confidence that these numbers are not totally crazy. For time horizon, you see a lot of scientists showing up at the top, and then you see a lot of manual work, again, showing up at the bottom. More examples, hopefully validating your priors. Cool. Okay, now we're going to bring the 2 exercises together. So remember, we have these automation scores from Olundu for all the models over time, and then we have these dimension scores on all these different task dimensions. Let's focus on physical presence because that's pretty intuitive. So remember, a 3 means a task is very physical. 1 means it doesn't require physical presence. And then we have our automation scores. So you can see that with high physical presence, it's very hard to automate, right? There's like very little red or purple at the top, and most of it is a 0, right? You're not able to automate. But then for things that have a 1 on physical presence, which means they're mostly like cognitive jobs, your scores are much higher. So this is sort of just validating the approach. Okay, here's I think what the coolest result, which actually surprised me. This sort of came out cleanly. This is looking at the share of tasks with an automation score of T3 or T4, so like highly automatable, if you remember the 90% or above. This is plotting over time when the models were released, the share of tasks that have that automation score of T3 or T4 within a given dimension category. So remember, 3, the green lines, will be things that are hard for AI. So in this case, it would be very hard to verify outputs, and blue would be really easy to verify outputs. And you can basically see the slope is much lower for the green line than the blue line. So the way to think about this is, according to GPT, looking at the descriptions of tasks and grading how easy they are to automate or not, the things that are hard to verify are not improving that much over time compared to the things that are easy to verify. If we look at time horizon, you get a similar result, but the slopes are not as different. So perhaps the divergence that we see for output verifiability is not as strong for time horizon. Manual work, and this is the one where I think it's the most intuitive, you see the biggest divergence. That's reassuring because even O3 can't do like jobs that require hands, right? So even the fact that there's even a slight positive slope is maybe even slightly concerning, but the fact there's a big divergence, maybe we're getting some information from this. Okay, what if we extended this to all the tasks, or sorry, all the dimensions? It's going to take a while to go through all of this, so I'll just call out a few insights. One is if you look at cognitive, analytical, and cognitive interactive tasks, I think it's interesting that you see positive slopes, you see improvements across both the hard tasks and the easy tasks. Whereas for social skills and manual work, you see larger divergence. So going back to the framework we were talking about at the beginning, this suggests that things like social skills, manual work will matter a lot more in terms of explaining the differences between AI and humans in terms of where their source of comparative advantage. Okay, yeah.
Just like interested on thinking about the developers sort of like trying to evolve these systems. They also like follow certain like profit motives as well, and they might be like trying to see where are the gains in terms of like demand. So I was wondering like how much that could also just like be caused by the fact that like they know the case uses for ChatGPT that consumers will actually be more prone to be happy about and things that they don't.
Yeah, there's like some market size directed technical change kind of thing going on in the background. Yeah, that's not something that we explicitly made. Maybe that should be another dimension. I guess you'd have to go from the maybe the wage bill of work would be an interesting thing to think about. Yeah.
I was just wondering, like, if you see this as just like a natural result of the way that the development is coming, like it's just like a technological feature, or is this actually like a result of like responding to
incentives like evals that are created, et cetera. We should talk about this in the break because I think it's a really interesting question, but yeah.
Is there kind of like, is it possible to say kind of which tasks are with LLMs like not possible to automate at all, right? Because like, I mean, I think it's kind of in a like trivial side in some sense that manual work can never be done by LLMs because they're not supposed to do that, right?
Yeah.
Like, now you kind of have to, if you think about manual work, you also have to incorporate robotics, right? Like you interact with those tools. So like, is there some sense of like saying, hey, this is not automated, like this is not something that LLMs can do at all?
Can
this out completely?
You mean ever?
Yeah, I mean like like LLMs themselves, right? Like
we'll never be able to do something. Yeah. So I think that's an interesting question. If that is something that the information that GPT can glean from like the model cards or the ONET task descriptions, like possibly it'll show up here. I mean, you see for T4 automation, which means 100% automation, like for example, manual, a lot of these things are basically flat, right? Like it's sort of getting at that idea. Things can change in the future. Let me keep going just because we're almost at time, and then let's talk more on the break. We're going to project these things forward. Take a leap of faith. This is saying thinking about AI timelines. At what year will the share, if you took those linear extrapolations seriously, would the share of highly automatable tasks that are easy to do, so score of 1, be greater than 50%? You get timelines of 2050, 2060, and so forth. If I look at dimension 2, which would be things that are intermediate difficulty, timelines get extended further. And finally, you get really long timelines and also a lot of variation in timelines across different dimensions for the things that are really hard for AI to do. And the thing that I want to stress, the kind of takeaway from this is like the notion of an AI timeline sort of doesn't make sense in on a single dimension. You should really have many timelines depending on what dimension of task or what dimension of intelligence you're talking about. And we're seeing, as mentioned earlier, growing divergence on some dimensions. We're thinking of taking this to a quantitative model similar to Anton and Kornek and Sue's paper. And one result you might get if we did this is, if you were to simulate what are the economic implications of, continued progress that's jagged. Suppose you had two types of workers, long-term thinkers and short-term thinkers. You might get like the wage collapse for short-term thinkers comes before long-term thinkers. Just as an example, I'd be curious if you guys have any thoughts on what would be most interesting to see in taking this to a model. Cool. So just to conclude, I think the takeaway from here is intelligence seems to have multiple dimensions. We've talked about a few of them. The evolution of AI progress seems to be preserving this jaggedness and actually growing it in some cases. And AI timelines might vary a lot depending on which dimension you're talking about. I think one last point I'll just mention that's sort of different from what we've talked about, but I think is intriguing. If intelligence is not multidimensional, then AI would not be steerable, right? You need multidimensionality for the concept of steering AI in a particular direction, of creating, for example, a pro-worker AI to make any sense. But even if AI is not steerable, suppose like to your question, it didn't matter what the labs want to do and AI progress was just a fact of nature and the ocean was going to flow, multidimensionality would still matter because, for human comparative advantage. If you think back to the original early graph we looked at here, suppose it's a linear, both are a straight line with only one principal component that explains all the variation, it still matters if AI and humans are different. So that's sort of the punchline for why you should care about this. Anyway, thanks.